cambiar vidas,
change lives,
change organizations,
change
दुनिया में
organizations,
बदलाव.
Change the world.
Well, thanks for having me here and inviting me here to give a talk on what I titled Autonomous Vehicles, or the subtitle from one of our researchers who once said, well, we drive our cars to work, should they not drive us to work? So, and that's a little bit of a challenge for one, but also obviously a little bit of a thought to chew on a little bit more. And that's to some extent what I want to do over the next roughly 60 minutes or so. But I also want to connect it a little bit more with literally connected vehicles, but also electric vehicles, to hopefully come to something what I call in one of the other classes that I also instruct here on campus, which is titled The Future of the Automobile. And hopefully that fits nicely with the theme Smart Green City, which is obviously the title here for this theme roundtable. And to be clear, I will be talking about automobiles. I'm not going to be talking about public transportation, mass transit, and so on. Not that this wouldn't be important. I'm a huge believer in very different modes of transportation. From my last name, if you pronounce it the German way, where I'm from Germany, then you would say Beiker. So that obviously means I'm a lot on my way on two wheels, actually a bicycle. I don't do motorcycles. But that tells you I'm really into mobility to a large extent. And a little bit about my automotive biography, which Marguerite already summarized. So I've been one way or another involved with automotive research for more than 20 years. The picture there on the left is about 25 years ago, as you can imagine. And I've been very, very early on interested in the technology of automobiles. So I have a PhD in mechanical engineering, looked a lot into vehicle dynamics, so how can you keep a car safe on the road and everything, which eventually brought me to BMW now about almost 20 years ago, where I worked in vehicle dynamics control systems, where I worked in innovation management, and eventually this brought me here to Silicon Valley, where I worked on what innovation can you put on an automobile to address all these challenges that we have. And through those assignments, especially the innovation management and then also the technology scouting here in Silicon Valley with BMW, I got very, very interested in what is beyond the automobile. And eventually I got into what I define as mobility, meaning the use case of the automobile. So look at the automobile, but also at the person using it. And eventually I came here to Stanford University now about 4 years ago to run what is now the Center for Automotive Research here at Stanford. So that's a little bit as a CV or bio, a little bit of a rundown, a little bit more animated. And this is the continent where I'm from. This is the country where I'm from. Obviously a great place for automobiles there in Germany. I grew up in the north, went to school in the middle of Germany, made my way down to Munich, BMW. Then this is not to scale. I got transferred to the United States with BMW. BMW wanted me to go back. We found a compromise that I actually stayed in Michigan for about 3 years. And then 2008, I came here with Stanford University. To start, what is the Center for Automotive Research? And if we had a little bit more time today, I would happily like to invite you to our automotive lab here on campus, which is about a mile across campus. A state-of-the-art research facility where basically all the automotive work is happening that I'm going to describe a little bit more in my little presentation here today. A few pictures there from the inside of this lab where we have autonomous vehicles, where we have electric vehicles, where we have student-built vehicles, where we have solar-powered vehicles, where we have driving simulators, and all of these things. And what Stanford really does, and you might be wondering, Stanford University now also automotive. You obviously know, or probably know Stanford more like this is where the Google search algorithm comes from, and many other things very renowned and popular in the IT world. But automotive topics here at Stanford have been around for, let's say, about 20 years or so. But when we got this research building a little bit more than 2 years ago, it really brought all these different researchers together who are actually looking at what I define as mobility, actually the connection of the human being and the automobile, and how do you use this automobile, and what should be done and what maybe should not be done, because we all know, true to the motto of this roundtable, I guess, here, smart and clean cities, that there are also a lot of challenges that we need to address. So just in summary, a little bit of a rundown what the Center of Automotive Research is. It's actually a group of now 17 industry partners. Many of them, you recognize the logos in the automotive space, but also we go beyond that into the IT companies, into service providers such as car insurance companies and so on. So really bringing, if you want to use the word, bringing the ecosystem together where you really define how an automobile is being used. And out of this, we are first of all advancing research and education in that field, but also initiating a lot of the new research programs. And Marguerite was mentioning one, legal aspects of autonomous driving. That was something that we definitely helped to get started here on campus through our program. And I will knit this in a little bit more throughout my presentation. Now, how we looking at the world of personal mobility, so using an automobile, what are the challenges? And maybe you looked at some of these numbers already one way or another earlier today. I could imagine, sorry I was not here, but I could imagine that you looked at pollution, or basically how many billion tons of carbon dioxide automobiles, or basically transportation sector, is generating in the United States. And then you can make up all these statistics that private automobiles are using more than 20% of the petroleum in this country. Basically, these are staggering numbers. And there are also some very staggering numbers, and this is at least one other topic we are very, very closely looking at, which is, I call it here injuries, but we should really call it fatalities, which is that in 2010, I don't have the numbers for 2011 yet, but in 2010, there were more than 32,000 people killed in traffic accidents in the United States alone. Worldwide, actually 1.2 million people who died in road traffic accidents. And 95% of these cases, the cause can be, at least to some extent, attributed to human error. So just that we are not the good drivers that we always think we are, just that we are maybe overestimating our own capabilities of controlling the vehicle, that we are maybe driving too fast, that we are maybe doing other things while we are driving, or maybe we are not well rested or other things. So basically that then accidents happen. And also one other aspect, at least we're looking at, is what's labeled here congestion, or let's say that the traffic is not as efficient as it should be. And I guess this is another connection there with the motto of this round table here, smart and green cities, where we say the average commuter in the United States wastes about one entire work week, so 36 hours every year, because the traffic is not as efficient as it should be. So the entire commute is much longer. I think the average commute per year is about 100 hours. So you can say about 1/3 of that is because there's too many vehicles on the road. Or if you want to flip this around, there are too few people in the average car, which is about 1.4 people that are sitting in every car that typically have at least 2 seats. Average seats per car is probably around 5 point something. So what can we do with all of this? And so how we are looking at this, it's 4 main topics. And the first one I will take a deeper dive into, and then the other 3 I will scratch a little bit more on the surface maybe. Driver assistance, that is something that I want to discuss with you in more detail. So we will be talking about autonomous vehicles, what's the idea about those in general as a future vision, but also how far have we come with this technology. And the other topic, connected mobility, really if you make the automobile part of the internet, just imagine all the data that you get from a car, that you get to a car, how much safer, more efficient, and also more sustainable traffic could be. And then obviously connecting with alternative energy. So we are looking on the one hand on electric vehicles, on the other hand on low carbon fuels. I understand that you had already a very exciting discussion probably earlier today on these topics. And so this is also where we are working closely together with our very dear colleagues at the Precourt Energy Efficiency Institute. Jim Sweeney was here earlier, Francis SPRIE is still here. So we are also really being an integrative part with many other researchers here on campus. And topic number 4, which is very dear to my heart, but it's maybe the smallest plant in our garden, if you will. We need to nurture it a little bit more. That is really how do we use the automobile? So true to this motto, mobility, use cases, and so on. So this is about car sharing, carpooling, ownership models, but also changing demographics, such as depending on your own personal background, but you might also be observing that the younger generation has a different identification with the automobile. That at least when I was getting a driver's license, it was really something, okay, which car can I drive? And it was very exciting. And maybe generations before me was even more exciting. And now currently it seems to be something that getting an unlimited data contract for an iPad is actually more exciting than getting daddy's key to the car or something like this. And I'm not saying that we want to change that, because I'm always saying we are not the drug dealer who tries to sell a car to everyone. There are definitely other people in the business who are trying to do this for a number of reasons. But we really want to look at mobility, because one thing seems to be clear: the demand for mobility is not really going away. And of course, we could discuss public transportation in length, and I would be more than happy to do this, but I would be more a layman than an expert, I guess. But assuming that every once in a while you do want to use a personal automobile to get to places where maybe public transportation does not run, or you want to use an automobile at a time where the schedule is maybe not convenient for you to travel, so then obviously the automobile becomes the first choice. And then in this connection with demographic change, the younger generation might basically just say, you know what, I don't need to own a car, I just want access to an automobile. So that is definitely something to consider for you as you're discussing here today, sustainable cities, the whole idea of car sharing model, and then the holy grail of car sharing. How can you enable one-way sharing as opposed to you rent a car here, you go somewhere and you have to return the car. So this is also some things that we are working a little bit on, but it's really more of a side topic beside those 3. Now, there are a lot of gaps in between this, and really to highlight how are we running our operations here, or how we are directing research, better said. Certainly technology and design is very important to that, and our program in general is organized in the School of Engineering. However, me with a background in mechanical engineering and having worked at an industry company for quite some time and having worked in innovation management, I actually saw that having a great technology solution is part of the equation, but it's not necessarily the solution. Because you might come up with a great battery for an electric car, but it might be way too heavy or might be way too expensive, or there might be chemicals in it that you cannot recycle or something like this. Or you might come up with a lightweight vehicle that really gets you 80 miles a gallon, 100 miles a gallon, but it's not convenient for people to use. They might not be interested in that. So you really need to look at many other things. So economics and business considerations, obviously. Can you turn those things into a viable business case? And that's obviously very, very important for the personal automobile, because after all, we are talking about individuals making a decision within an hour, within a day, within a week, maybe within a month, but then they are locked in and they're going to use this device that they're purchasing for 3-5 years and so on, with all the implication that this thing might have. So very different than if you're looking at maybe operated fleets, or even more like maybe military equipment and so on, where certainly business economics are also important. But this piece is basically about one of the very few incentives that you have in order to make people make the right choice regarding an automobile that addresses all these challenges that we looked at. And then somewhat connected to this, sociology and psychology. So do people like the product? Do they feel safe in the product? Do they perceive a safety in the product? Do they trust a certain product? So many of these things. Politics and policies in the introduction we mentioned already. Legal aspects of autonomous driving. So what you will see on one of the, I think it's actually starting with the next slide, a car that drives itself, who's actually responsible for the actions of a highly automated vehicle. And then resource and environment, certainly. What is the implication for the environment of a certain vehicle type? And also, do we have enough resources to sustain the mode of transportation that we are promoting one way or another? So I would like to take a closer look at this driver assistance topic. And what does it actually mean? So we're talking here a lot about this field of autonomous driving. And what this means, there's an automobile that has a fantastic brain inside that collects a lot of sensor information and then can automate gas, brakes, and steering, basically. The sensor information, for one, is GPS information so that the car knows where it is on the planet, and very similar to your GPS system that you might be using in your car, or basically just if you're walking around on your handheld device that guides you to a destination and tells you turn left, turn right, and so on. So you could almost automate that. However, you don't know exactly what lane you are in. You don't really know if there's an obstacle. You don't really know if there's a detour that you need to account for. So you need additional things such as laser, camera, and radar sensors so that you see an obstacle on the road, that you can avoid that obstacle, that you can plan for an alternative route around an obstacle, or maybe a side street or something like this. And you take a few additional sensors here, so very accurate wheel speed information or motion sensors so that you really know how your vehicle is moving and where it is exactly in the lane. And then you can basically say, okay, I see an obstacle there, so I want to steer a little bit more to the left around that obstacle. I want to brake maybe in front of an obstacle, or I want to accelerate in order to enable an efficient traffic flow. So far, the theory. If you basically know about your car, where it is, if you know about the environment, if you know where you want to go, then you can basically automate, again, gas, brakes, and steering. And what you would end up with is probably a reduced risk of human error, because if you're taking the human out of the loop, then we saw 95% of all accidents can, at least to some extent, be attributed to human error. So we are not believing that we can drive this down to zero, because after all, there will be humans generating the code for these automobiles, humans that will design those sensors, humans that will manufacture those vehicles. And also there, unfortunately, mistakes happen. But probably we can drive this number much, much lower. And also we can probably improve efficiency of the traffic flow, because let's face it, we are not very good actually at adjusting to the speed of a car in front of us, or to actually keep a close following distance. And there are some of these numbers, just a random highway here in the Bay Area, so they took some pictures. A highway at a peak hour where you basically have more or less gridlock on the street, and if you take an aerial image of this highway, you still see that only about, I think, close to 20% of the surface area is being used. So 80% is not being used. And that is basically because you need some distance between those vehicles, so the left, to the right, to the front, and to the rear, because otherwise those cars start obviously bumping into another, and you end up with even more friction in your traffic flow, which you certainly don't want. But that tells us actually how good we are at controlling our automobiles. And so the assumption is, with very accurate laser, radar, camera sensors, and so on, that you can create a much more efficient traffic flow. And there, hopefully, not build more and more streets, wider streets in the city, but actually increase the throughput. And then also, that is somewhat connected to this, improve efficiency of the vehicle control, which basically means that you, as you're generating a more or a smoother and maybe more forward-looking traffic flow, that also the energy consumption is lower than what you might have if the human being controls the vehicle. So how far have we come? And this is an image, or well, it's not just an image, obviously an animated image, from the DARPA Urban Challenge that maybe some of you are familiar with. So this video is going to run for 4 minutes, so I can definitely talk about a few more things in that regard. So the DARPA is the Defense Advanced Research Program Agency, so the research branch of the United States Department of Defense. And they called for the grand challenge in 2005, where they actually said they wanted to have a driverless vehicle for a race in the desert so that they can actually showcase a technology that can be used in the military later on. They did this in the desert in 2005, and in 2007 they did this, which is the urban challenge, where they had obviously a more urban setting where the cars needed to follow the California traffic rules. And this car here, there you see, I hope you can see my little mouse pointer. There's the laser sensor on top of the car that rotates at 15 revolutions per second with 64 beams that sweep around like this and basically gets a very, very precise image of the surroundings. So in the previous picture when you saw laser sensor, laser scanners actually there on top of the car. In addition, it has GPS, has a few radar sensors, and there's no driver in this car, only these little Ford Tauruses. They are not small, but these Ford Tauruses, they are vehicles driven by human beings, by stuntmen actually, stunt people. And so these vehicles, this is an animation of what the sensor sees. There are no people in there, they only have a remote kill switch, so if something goes wrong, they could stop the vehicle at all times. But here you see what the laser sensor sees. Gets all the reflections from the people, even over here, obviously from the other car. It just saw that there's a gap long enough to merge into traffic. It did know that there was a stop sign here. It's supposed to go to this next waypoint. So this is a GPS component of it, very similar to your GPS system that you might be using. And then in between, it sees that there's obstacles that it wants to avoid. And then someone needs to put, obviously, in computer code if you are supposed to stop at a stop sign, if the other vehicles are supposed to at a stop sign, or if you can continue to drive. And here now there's a very interesting situation coming up that you saw in the video earlier. This is now the same animation of the same situation. Now there's one vehicle coming up, could have done this turn. Maybe a human driver would have done it, but this vehicle is very courteous and safe, so it doesn't drive in front of this car, doesn't merge now, doesn't merge after this one, it merges after the third vehicle. So you can program this. You can probably understand, those of you who have experience with artificial intelligence, that's a term to use here, obviously, because it's artificial decision making, that you can program all of these things. But the question really is, what happens if something goes wrong? If there's a situation that you could not foresee? Because it's understandable that you can program a stop sign, what the car is supposed to do, that you can program a speed limit, that you can program emerging onto a highway on any of these things. But what if there's all of a sudden a situation that you have not accounted for? If there's a ball running into the street, us humans basically know that a child might follow. Or what if there's a situation that you have to make a decision, you have to avoid an accident, and your decision is you can run into an abandoned shopping cart that is in the street, or you can run into a little perambulator that is on the sidewalk. From a radar image, it might look very, very similar. But obviously the outcome might be very, very different. So this is what they did here. I want to show you one more example of the research that we are doing here. While the first example that I showed you was computer science, artificial intelligence, really using a lot of computer vision, decision-making, machine learning, and putting all this into a car. This other example that I have from our researchers in the mechanical engineering department that are looking much more at the vehicle dynamics. So basically, how does a vehicle behave at the limits of handling, which is really when you're getting to the friction limit where the driver needs help, because again, 95% of all accidents can be one way or another attributed to human error, and that means the driver was just too fast going into a turn, so how can you rescue the situation? And this is a video from now about 2 years ago where Professor Chris Gerdes with his research team went to Pikes Peak Mountain. As you can tell in this car, there's no driver sitting in it, it can navigate Pikes Peak Mountain, very challenging turns and climbs up the hill. And in quite some sections, they were definitely getting very close to the limits of handling, and the vehicle could handle the situation very, very safely. To be clear, this is not necessarily about animating drivers to go as fast as possible. But sometimes maybe if there's a slippery road surface condition, you just end up being too fast, and then you want a control system that can help you there. And this is a very good example where you can combine this control at the handling limits with the computer vision and machine learning that you saw in the earlier example. So this is basically telling you we are getting already in research vehicles very, very close to very smart vehicles where the driver doesn't need to be in the car anymore. In both vehicles, there was no driver. Now, how far have we come with all of this? The idea of automated highways and autonomous vehicles is not exactly new. And more than happy to discuss the distinction between automated highways and autonomous vehicles. Let's just say for now they are very close fields overlapping one another. Actually, in 1939, GM was showing at the New York's World Fair a concept which was called Futurama, where they had, you cannot really see it in this image down here, but that's the best I could find, where they were showing basically vehicles driving automated on a highway. Basically, they were getting some information from the highway infrastructure, and then the vehicle was controlling steering, brakes, and propulsion according to the traffic and road conditions. And back then in 39, they said they would have this in 1960. So that's kind of interesting. In 1939, the big vision was what's going to happen in 1960. Well, to release you from this little quiz, it did not happen in 1960. And throughout the years in the 50s, 60s, 70s, and so on, it was always like in 20 years from back then, they would have these automated highways, which is more in the bluish color here, and then eventually it got more into these autonomous vehicles where everything is self-contained into the car, doesn't need that much highway infrastructure. And it was always something like 20 years out to the future. And that is something that really needs to be assessed, and also when you might be discussing this topic a little bit later, maybe around here, more than happy to do this together, or maybe when you go home to your respective organizations, you will be discussing automated highways, autonomous vehicles. Be careful. Be careful with the conversation, because very, very often you hear something in 20 years from now, we don't need drivers anymore. But we really need to take a very close look what is really possible. So the latest thing, what we have here, our grand challenge from DARPA and whatnot, Google is obviously now working a lot in the driverless vehicle or autonomous vehicle space, just a few miles down the road here. Very accomplished in the year 2011. So about a year ago, obviously, they claimed that they had driven 160,000 miles without any driver intervention on highways here in California and in Nevada. And that's very, very impressive without any question. The question is, how do we move on from here? And when can we actually put a nice little diamond on there? First autonomous car handed over to a customer. So let's see what we've accomplished so far. And some of this might be known to you. So what we have actually in quite some high-end vehicles these days is what is called adaptive cruise control. So there's a radar, sounds familiar to the overall setup that I showed you earlier, but a radar in front of the car that basically senses a vehicle in front of you and then slows you down automatically, speeds up again if the highway is clear, and then if someone merges into your lane, it slows you down again. So this can more or less take care of for one, safe following distance, second, also for a more efficient traffic flow, and third, obviously for less driver workload in that regard. So that is more or less a longitudinal control where we are already getting relatively close into the field of autonomous or automated driving at least. Slows you down all the way to a standstill, but this is where it's getting tricky again, and this is the question what we had earlier with the legal topic. So when it comes to a standstill, when should it drive off again? So you might say, sure, it should start driving again when this vehicle starts driving. Right, but what if the driver is just searching for a notebook somewhere in the footwell on the passenger side of the car? Or what if the driver is just turning around to the rear seats to check on his or her kids, what is going on there? So how do we actually know that you can drive off and the driver's actually paying attention? And this is already telling you, of course, you can show many things in research. You can have great systems already in the car, but to really make sure that the entire vehicle will be autonomous, there's a huge challenge. Somewhat similar with the lateral control, what we have here. Yep, don't need the sound for this. Well, basically, if you get very close to the lane markings, that you get feedback in the steering wheel. And for now, we are more in the field where you get a warning for to basically pay attention and keep the car in the lane. But we are now already entering the stage where the vehicle is able to steer itself back into the lane. So this is, if you will, the lateral control, and they show it here on a straight highway, but you can imagine that going through curves is maybe a question of time, maybe a question of better sensors and so on, but you can do so many things. You can basically say if you combine those two systems, then you have it already. Some other things, I guess I want to speed up a little bit with this. This automated parking, this is a Toyota Prius, the showcase of one of the first vehicles in 2003. The automated parking, where basically the steering is all automated. You just need to control the velocity of the car, and with, in this case, some ultra sound sensors, it basically maneuvers into this parking spot. Some of them use cameras as well. Works very well, and obviously it's a great relief for people trying to find a tiny parking spot in the cities. And these things are being perfectioned more and more. A little bit more on the safety side. This is about maybe how far we've gotten so far. Volvo's city safe system that basically brakes for pedestrians. It uses a camera and a laser and radar combination. I'm not exactly sure, but definitely a camera sensor as well. So it first sounds an alarm and then actually applies the brakes to avoid a fatal accident, probably. But still there, you can imagine, how do you make sure that your sensor sees a person and not a plastic bag that is maybe being blown across the road? You obviously want to brake for one, but not necessarily for the other, because there might be someone very closely behind you, and if you slam or your system slams on the brake and someone rear ends you, that might be challenging as well. So the roadmap, you saw like 4 slides earlier, the roadmap, how far we've gone on the research side. This is the roadmap, how far we've come and where we might be going with production systems. So this field of driver assistance systems started maybe with ABS, analog braking systems, in the late 1970s. And then we got here with the adaptive cruise control that I put here. Adaptive cruise control that you saw earlier, so the system that adapts the following distance to the car in front of you. That was in the late 1990s. And we are now here in this space where we see lane keeping assistance, a little bit of automated parking. We see like 4 different levels of these systems. One is warning, just a warning to the driver, like wake up, pay attention. Assisted driving, where there's some overlay that the system helps you to maneuver a situation even better. And then the automated driving, as we might want to classify it, which is it only helps you in certain situations. So just the parking, just the highway driving, just the stop and go traffic. And then finally, the fully autonomous driving, with the idea you enter an address into your navigation system, you press a button, and the car drives you there autonomously, what you saw earlier from this urban challenge, so the very first video that I showed you, that would enable that. But as you can tell here, I'm not really claiming that I can tell it's going to be in 20 years. Because if I said what many people say, we will have this in 20 years, I might not be, or I'm not in a position to say this, so we'll see, but we're definitely working on it. So the Google car, what they are doing, maybe some of you saw this video, this was like their little stunt that they showed at the TED conference about a year ago, I believe. And all these videos are on YouTube basically, so you can look them up, where they actually showed that this Toyota Prius with a Google autonomous driving algorithm almost becomes a race car. I think if we put on sound, then you hear. They are going pretty fast. If that helps the purpose, I leave this to you. Definitely not in terms of smart and clean cities. But it's obviously supposed to show how far they've come with the technology. So there are people in the car, but no one's driving. And so that shows obviously the accuracy of this technology, what you can do. And all the headlines that you find, I just picked a few, might let you believe that this is happening anytime soon. And some actually talk, so very close to maybe your topic here, that this might revive urban sprawl, because if you don't need to drive anymore yourself, you can do other things while driving, so you can maybe move to the outskirts or to the suburbs and maybe even further, just because if it's like half an hour or an hour commute, and if you can be productive while working, so why would you care? And now we have more and more initiatives in different states here in the United States where those autonomous vehicles, driverless vehicles, are being legalized. And that would be a long discussion in itself, what it means that they are being legalized. Are they not legal if they are not being legalized or something like this? This is actually where we created this program that Marguerite mentioned, legal aspects of autonomous driving. So we have a researcher working full-time on this. He actually started about a year ago, and for about the first half year he tried to figure out an answer to the question if autonomous vehicles are legal or not. And guess what? This was a typical answer from a lawyer: well, it depends. And but mostly yes. So that was his assessment. So is it really that close that we will have these cars? So I'm currently trying to identify an answer for you where back to this scenario here where we can put this marker. And so this is another picture actually from 1970, a book that my parents got back then, which was about the vision for the year 2000. And when they were also talking about these automated highways and people can watch TV and play cards and whatnot and have a good time while moving along. Well, the thing is that traffic typically doesn't look like this, because traffic typically looks more like this. So you want to account for all these things that can happen while moving along with your car that you just cannot program into an algorithm for your autonomous vehicle. And therefore, you really want to think about what we need to do in order to get those vehicles on the road. But I don't just want to leave you with questions and something like, well, he showed us these great videos and then he said it's not going to happen. So I have about 15 more minutes to maybe enlighten you with some solutions. And this is where I want to tie those three fields a little bit more together, like the autonomous vehicle, the connected vehicle, and to some extent also the electric vehicle. So the question with this autonomous car is, and we saw this picture earlier, if it actually works without infrastructure. And this is where those two fields, autonomous car, autonomous meaning independent from each and everything, totally self-contained, and the automated highway. So a lot of infrastructure on the highway roadside that communicates with the car, that actually makes sure that the car gets information that it needs about the road itself, about the traffic, about other vehicles, and maybe also about some time-sensitive information. So we are talking about V2V, what is called vehicle-to-vehicle communication. So what if vehicles could talk to one another? And there was one program last year from the US Department of Transportation was engaging actually high school students and college students as well. If cars could talk to one another, what would they say? And that's not a trivial question, because for one, you can exchange all sorts of position, location of the car, velocity, where the car is going, and all of these things. You can even exchange information like, I'm a small compact vehicle, I'm a 40-ton heavy commercial duty truck, and that's important information obviously when it comes to a collision. And but that also tells you already at least two things. One, how do you standardize a communication. Of course, you can show in a research setting, well, you know what, we can send packages of data from one car to another. But how do you make sure that all the cars from all the different brands, all the different manufacturers can actually talk to one another? And then obviously there's a huge question about privacy. Well, I never really said I wanted to share this information with this car. Or, well, what do you mean? Can you track me now where I'm going and how I'm driving and all of these things? So as you can imagine, technology-wise, that is possible. But are we ready to do these things just yet? And what are especially the non-technical challenges? And this is what you saw in my little puzzle that I put on the different puzzle pieces. If you have a great technology, fine, but address the policy issues, address the human subject or the human aspect, address the economics and business concerns and so on. Somewhat similar vehicle to infrastructure communication, V2I, where you basically want to exchange information with the roadside infrastructure, maybe with a beacon that is sitting there on the side of the road and broadcasting speed limit 35 miles an hour, something like dangerous intersection, slow down, or something like it's wet this morning, you don't want to go so fast, or whatever information you might want to broadcast. And then also something that was used in quite some of these 1960s till about 1980s automated highways. It might be little magnets in the road surface that some of you have heard of, basically for accurate positioning for the automobile. That's maybe then connected to a centralized traffic management, traffic coordination center, and maybe offers something like, today we have these carpool lanes where only vehicles with at least two vehicles are with at least two occupants are being allowed to drive. There maybe in the future there are special lanes for only autonomous vehicles. And that is something where, again, we could discuss this 20-year horizon, 20-year time frame. When I showed you like 2 slides earlier, there might be a dog on the road, there might be like law enforcement on horses, or there might be a congestion, or there might be a truck facing rearwards. Many of these things might not happen in a special lane where you say, you know what, only autonomous cars go into this lane. And this is something where we need to be on the lookout, what might be happening within this 20-year time frame that is always being entertained for autonomous vehicles. It might be something, and maybe it might happening in your backyard, hopefully not in your backyard, but maybe in your environment where you are visiting us from today. They are just interest groups getting together and say, you know what, we just purchased a highway, we just allow autonomous vehicles on there because we have the money and we want to get to work and don't want to waste time driving. We just pay for the entire system. So that is a conversation that I had the other day, actually it was about half a year ago here at Stanford. I think there was a meeting that we also had in the Precourt Energy Efficiency Center when we were discussing climate change and the impact of transportation and so on. And one of the faculty, actually from Princeton University, said, you know what, it's just a nightmare, the commute from Princeton, New Jersey, obviously, into New York City, Manhattan. I forget which highway it is, which interstate it is, but apparently it's a very congested highway. And he said, well, you know what? There are all these lawyers and all these portfolio account managers living in the outskirts, and they need to drive to New York City, Manhattan every day. They make about $1,000 an hour, and they are stuck in traffic for at least 1 or 2 hours every day. It doesn't make sense. They would be happy to pay maybe $20,000 or something like this to get access to this autonomous vehicles only lane or something like this. They might be happy to pay for an additional infrastructure, and they might be happy to pay for a car that is, with all the autonomous settings and so on, costs maybe about $20,000, $30,000, $40,000 extra in addition to your Lexus, BMW, Mercedes, Acura, what have you. So this is just showing where it's a little bit unclear how we approach this topic. Definitely, we will need some sort of infrastructure to deploy a completely autonomous car. But it might be something where we don't really see it spread out overnight throughout the entire country. But really more like, you know what, there's this highway where this is starting. And we were just discussing earlier today when I walked in, Highway 5, for instance, here in California, where not much is happening. if you're driving down from here to San Francisco, to Los Angeles, or maybe even from Seattle up in the north all the way to San Diego. Not much happening on that highway that you can actually have a lane only for autonomous cars. And yeah, so we touched on this basically earlier, that connecting the car to the internet in general. So this is very brief. Some people say the car is not really a smart thing, and my smartphone is much smarter than my car. Well, that's not true. This is just a list of all the information that a car has, knows about itself, uses, but doesn't really share with its environment. And this is something I want you to keep in mind maybe. The car knows so much, even it knows about the weather, if you will. It knows if it's raining or not because it has this automated windshield wipers. It knows about certainly temperature and ambient pressure because it needs all this, not just to display to you outside at 68 degrees. It needs this to run the engine efficiently and as clean as possible. It knows about other vehicles, what we saw with this ACC radar. It really knows there's a car like 35.67 feet ahead of you. And it knows so many other things. Just imagine if it could exchange this information with other vehicles. There's a lot happening in this space, and I don't want to explain all of these pictures here, but just note on the left, we have the pictures from a US consortium, which is now called Safety Pilot, used to be called Vehicle-to-Vehicle Communication, Vehicle-to-X Communication, DSRC. There are many different words for it. Basically, it's a government-led initiative to actually make vehicles talk to one another. And on the right, you see the European program, which is called Car-to-Car Communication Consortium. And in Japan, there are similar programs. The pictures all look very different. You have these very nice Wi-Fi 802.11 circles around those cars so they can broadcast information, that they can retrieve information from other cars and so on. You have some ad hoc networking pictures up here, and you have all this magically displayed turn right at the next intersection. You will find your parking spot because a parking spot has an identification on it where there's a spot already reserved for you. Of course, you can do all these things. Big problem is who pays for the infrastructure for all of that. So this is why what we are working here at Stanford on is what if you could use existing communication system, not deploy an entire communication system with all the communication equipment and whatnot, but if you could use cellular-based and server-based architecture. Let's just assume a few examples what you could do with this. There's maybe an accident on the highway, and there's a server, and you can certainly, with all the information that I showed you on the previous slide, you can send a signal that an airbag has deployed and that the vehicle got damaged. You can send this to a server, and then you can have all these other vehicles. Oh, I'm going much slower than I would typically go on a highway, and you see that there are many of them in a small little quadrant because through cellular systems, you know that there are many vehicles in one small communication cell. There might even be something, there's an emergency vehicle that's being dispatched to go to this accident scene that puts all this information on the server. And then there are other vehicles maybe who are moving very slowly, or maybe some vehicle were on electronic stability control, so these systems that keep the car safe on the road, where there was an incident. This is all information that's available in those cars. And what if you could put all this information on a server with a little geotag, location tag, where exactly this is happening. Even you could put some road closure. And then there's this other car entering this scene and asking, well, what is happening in my area? So this car could pull all the data from the server, and then you would know what is actually happening in that you don't want to go on this highway, that maybe it's a slippery road condition because there was already one car that was skidding out at a driving situation that would typically not be dangerous. So you can make this traffic much, much safer. And you can do similar things. I want to advance this a little bit quicker because I want to wrap up this presentation here. You can also do some other things. When do I get to my destination? Well, there's no much traffic going on. You can If you enter a certain intersection, well, is this a dangerous intersection or not? You can actually do some social things. Who's this person driving next to me? And then you can find out, you know what, you are both have a mutual friend on Facebook. So all of these things is information that can be provided because it's information that we're carrying around with us. Obviously, we end up with a lot of communication that's being broadcasted. And this is where we are initiating research now. For one, what are the latency requirements? Because obviously, if you want to exchange information, who's this person there on Facebook, it's a much different requirement than if you want to prevent an accident. And also, what is the bandwidth if you just want to exchange a location and maybe a velocity information? It's very different than streaming media over the internet or something like this. Lastly, to connect these three topics, autonomous, connected, and electric, I want to talk a little bit about electric cars. The big challenge for those cars are, as you probably know, one way or another, range, charging infrastructure, and cost. And there are some polls that I gathered here. For one, it's US consumers, how they see the world, what is preventing them from purchasing electric cars. 28% say it's range, 20% say the charging network, and 17% say they're just too expensive. And in the European Union, very similar, just a difference. Up here they were asking consumers, down here they were asking industry experts. The list is in the same order. It's range, it's charging stations, and then it's cost. And we can debate why these numbers are about twice as high as up here, maybe how they did the statistics, but the order is very important. So basically, this is why analysts expect by the year 2020, where many people are looking at right now, that all of new vehicles, and this is a US number, all of new vehicles in the market might be only 2 to 3% battery electric vehicles. So the question is, are consumers ready for electric vehicles, or electric vehicles ready for consumers? And with the range problem, I'm not sure if you discussed this one way or another already today, but what are the advancements in battery technologies? When can we actually have an electric car that can travel 200 miles and even more? And what are the charging requirements that you can recharge these cars just in 5 minutes or something like this? So we are looking at a slightly different solution here at Stanford, and this is an electrified highway. So what if you could transfer the power from the highway to the car? And there we are not looking at conductive power transfer or induction power transfer. This is actually magnetoresonance. So you have these magnetic coils in a roadside surface that are resonating at a specific frequency. We are currently looking at 10 megahertz, and there's a receiving coil here in the car that then picks up the energy from the road surface. Certainly a lot of infrastructure questions need to be answered, and the implementation cost. There are some initial numbers that indicate that this might cost about $600,000 per mile highway. But after all, highways as such cost quite a bit, and we are obviously looking at a very big problem here. And the interesting thing about this is, so this might not work for your smart city because you don't want to really rip up all the little artery roads and neighborhood roads in the city, but you would want to use this on the highway. Because in the city you have a relatively small battery, gives you a relatively lightweight electric vehicle, because it's a battery for maybe 50, maybe 100 miles, that maybe then weighs only about, let's say, 100 pounds, maybe 150 pounds or something like this. But if you want to go on the highway, you don't need your battery because you get the charge directly from the highway. And therefore, you actually end up with hopefully cleaner and more efficient vehicles in the city. So the interesting thing, and this is the infrastructure part in it, it fits together all very nicely. If we're looking now at this picture, we have the autonomous car, we have the connected car, and we have an electric car that is getting the power from the highway, where this power transfer approach looks somewhat similar to what we had earlier in here in terms of the localization of the car on the road, what we need for an autonomous car, that you can really keep the vehicle safely on the road, and certainly some Data management and infrastructure coordination is necessary for the billing of those electric vehicle services, and also to allow for a respective spacing of these cars so that the entire charging works out and so on. So it might be a very nicely integrated transportation approach for personal mobility, where you say it's automated, it's electric, and it's connected. So in summary, how far can we get with all of this? Let's just revisit those thoughts again. Nice scenario that we can all sit in our cars and watch TVs, or by then we might not be watching TV anymore, just streaming some other media. The technology would probably be ready to have autonomous cars today. But the big question really is, how do you mix the conventional vehicles, what we saw in these examples, what traffic looks really like? How do you mix this with these new autonomous vehicles that are not driven by humans anymore? And there we'll maybe say there might be potentially in a little bit less than 20 years on some selected roads automated vehicles. For the connected vehicle aspect, certainly technology exists to connect vehicles and communicate with vehicles on the road. Obviously, it's possible to communicate with vehicles on the moon, communicate with vehicles on Mars. So why would it not be possible to communicate with vehicles on Highway 101? But the infrastructure cost to deploy a completely new communication system is immense. So this is where we basically say that maybe with cellular technology, we can do some things, maybe not the full picture of all the different applications that we might want to do because of latency and coverage issues and so on, but some applications that we can do already very, very soon. And finally, there's a lot of technology being researched to enable long-distance travel with electric vehicles. And I do know that you are mainly focusing here on the city and city traffic, therefore, but remember that people don't really all want to own several vehicles, especially with a younger generation that says, I don't care about a car that much in general. So if there's a consumer who's happy with the car for long distance travel, then that's also the one they might be using for the short term. And if they say, oh, you know what, I might go on this long distance trip once a year, twice a year, something like this, and therefore they buy a not so sustainable car, then they will also drive a not so sustainable car in the city. So there's a lot of work on the long distance travel with electric vehicles, and but it's really unclear to what extent people will be adapting or adopting will be reaching out to the infrastructure that is available for charging those vehicles. So at this point, and this is where Jim Sweeney and I were actually having a panel at the end of this week, where we'll be discussing if electric vehicles are really a near-term solution or it might be a longer-term shot. So this is my own personal prediction maybe. I'm guessing by 2025 that the average electric vehicle might satisfy the average consumer needs, where right now it's like a very specialized mix of people who are really buying these battery electric only vehicles and are satisfied with the capabilities of this car. So that's a little bit of a summary that I wanted to give you on autonomous cars, on connected cars and electric cars, and how it might all fit together. So I know there are a lot of things in there, but I thought I'd tell you a little bit about the research that we are doing here at Stanford and also what's happening out in the market. And really, in the end, it needs to be an integrated approach, true to the motto in the beginning, where I say it's not just one technology that you want to put out there, because one technology will not solve all these three main challenges in terms of safety, efficiency, and resource requirements. So therefore, I truly believe a connection on all of these topics is probably needed. Thanks for your attention. And we would have time for some questions, I guess. Please.
This question is about your ideas about wireless charging on highway.
Mm-hmm.
Has anybody measure or estimate
the cost of the electricities, for supporting such highway, and if there's no car going through, do we still have, still need it? Does it still use the energy? And does that make the electronic vehicle no longer green?
Mm-hmm.
Just would like to see your views.
I don't have an answer for you for the concept that I showed, what really the cost implications are. And there are obviously many different levels of cost that one might want to look at. For one, it's the deployment cost, but you're absolutely right, it's the operation cost as well. So with our concept here, with this magnetic resonance charging, it would only transfer power if really there's a receiving coil on the other side that you transfer power to. But still, it's something, how do you turn the whole system on and off depending on the traffic that you have there. But I think what you are somewhat implying with your question, we still need to discuss more how much electrification of the transportation sector actually makes sense for economic reasons, but also for environmental reasons. And one slide that I did not include here, which basically says if you do the life cycle assessment of an electric car, if you really look at everything from the manufacturing of the car all the way to recycling, including operation obviously, then for one, depending on the power mix that you use for this electric car, but also what materials go into this car, and also how big your battery is, that it's not automatically a cleaner solution. So and the answer is we have not looked at all of these details.
A lot of the EV manufacturer didn't look at the whole picture. And and we don't really know whether EV really is green or not, because the battery could be polluting. Manufacturing of battery could be polluting, and battery need to be replaced. Every few years. So the overall, the cost to the environment may be even higher.
That's exactly right, and this is where I'm in my main position as running the Center for Automotive Research here at Stanford, where I really want to establish more of this life cycle assessment research here at Stanford. There are a few studies out there, some of them are actually from Carnegie Mellon University that I appreciate a lot, where they really try to make a very holistic approach to really all the different levels of environmental impact, and not just greenhouse gas emissions, but also emissions like sulfur dioxide or volatile organic compounds and all of this. And the challenge with all of this is we are using some models, and if we don't know anything better, then we use linear models. And sounds like that you are following this field, or maybe you are working in that field, I don't know, that you can really find arguments for basically both ends of the spectrum. One end is electric vehicles are clean, are green, are the best thing to do. And you can also find quite some arguments that support thinking that it's not a solution at all. And obviously the first thing one should look at where the electricity comes from. One of our very much appreciated researchers who actually passed away now about a year ago said that it's not an EV, it's not an electric vehicle, it's an EEV, an elsewhere emission vehicle, which basically means the power needs to come from somewhere, and if it's just coming out of a coal-fired power plant, then we don't actually gain that much, unless or except maybe a little bit better air in the city, but we might end up with all the emissions in the outskirts.
Okay, thank you.
Yeah, I'd like to ask a non-technical question. I know this is going to reduce the accident, but in case of accident, whose responsibility is this? Car manufacturer, owner, or maintenance company? Whose responsibility is this? Insurance company will pay for that?
Well, let's see. So this is really why I like, not sure if it's this slide. No, it's actually the next slide. Where I like this slide a lot. Where we really see, you might want to say this is maybe what the industry offers. They offer you a technology product, which is the car to a large extent. But it's really living in this tension field, if you will. So this is government, obviously, that makes the rules, and rules can be bent one way or another, but it's incentives and policies where we obviously see that for hybrid electric vehicles, for instance, getting access to this carpool lane was a big push that these vehicles are being purchased. To some extent, that's now the case for battery electric vehicles, where people might have very good intentions regarding this field here to save resources and to hopefully do something for the environment. But many of them might just say, you know what, because I don't get stuck in traffic, because I can get this incentive of using the fast track, that's something good. And then in the end, it needs to make economic sense for all of us. But there, of course, you can discuss what does it mean to make economic sense, because on this side with the environment, it's not really part of the equation. Of course, you can say how much damage does climate change do in how many dollars, or one very good study was being done in British pounds, obviously. I think it needs to be all of this, because if you just look at one thing, like this is what industry wants to do, that might not really connect well with what the consumer's interested in. Or if you just let the consumer choose, this is something, a slide that I did not include. For instance, when I do these classes here on campus and work with students, and I ask them, are you interested in purchasing an electric vehicle as your next car? About maybe 20% of the students say maybe. But most of them not. And then, of course, we can discuss, is it actually a sustainable solution or not. But you have to find mechanisms, obviously, to direct people more in the direction what is a sustainable or hopefully good solution for an electric car, where Francis SPRIE, for instance, does some great research in that field. So I truly believe it has to be something where industry, government, and consumer organizations need to work together, because otherwise we just get more of the same, which I personally think is not a sustainable solution in the long run.
Please, can you comment some words on the hydrogen fuel cell car? Do you see that's a substitution, or that have similar problems too?
I don't know too much about hydrogen, to be honest. I mean, I used to work for BMW, and BMW still has a relatively profound program on hydrogen vehicles, but not fuel cell. So they are going for hydrogen-powered internal combustion engine. But the challenges are very similar. It's obviously the supply chain for hydrogen. And then you can certainly also discuss, is it safe to have that much hydrogen in the car and so on. But it largely seems to be the supply chain, which definitely includes where do you get the hydrogen from. If you're just getting it from electrolysis and just split water into hydrogen and oxygen, that doesn't help you too much, because then you can just use it as an electricity to power a battery. My understanding is, to the date, the best way to get hydrogen is out of natural gas, and that the byproduct is carbon dioxide again. Doesn't really help you too much. And then how do you get the hydrogen to the gas station? And this is where we already see that such things that, like natural gas powered vehicles, where you need to switch the supply chain to the gas station, that is already a challenge. Not to mention the diesel is a challenge. Do you have enough diesel stations in the country for somewhat more and more diesel-powered passenger vehicles? So far about the hydrogen on the supply chain side. So in some of these discussions, my take on it is, well, we can look at the hydrogen-powered vehicle, we can look at the autonomous car, and there's one more actually, which is flying vehicles. So these are all things that have been discussed for at least since maybe since 1939, what I pointed out in my presentation. And technically, many of these things are feasible, but it just shows you how difficult it is to change the system that just works fascinatingly well. We just put gasoline in our car, takes us 3 minutes, and just we drive off and go to the next station a week later, a month later, or something like this. And this exactly to this point, how can you change this to just tell consumers, you know what, you should behave differently, or you should make a different decision, or you should purchase a different product. Just doesn't work like this. And then it becomes a chicken and egg problem. Do you have the infrastructure first or the product first? Who should commit first? So my take on this is autonomous cars and hydrogen-powered vehicles might have about the same destiny, history, and maybe might be the same horizon until we see them. And maybe it's the same with flying cars that I didn't touch on.
Yes, you misunderstood my question.
Oh, sorry.
My question was, in case of accident, whose responsibility is it?
I'm not sure if I then understand the word extend.
Accident.
Accident. Oh, sorry. Oh, I totally misunderstood your question. I'm sorry. Okay. You mentioned insurance. Okay, sorry. I definitely misunderstood your question. I was giving you a completely different answer. But I hope that this answer was educating and maybe entertaining as well. Well, that depends. Currently, you can basically say, unless there's a technical failure in the product, then the driver is typically at fault, is responsible, right?
I'm not driving the car.
Well, no, currently, if you take a current state-of-the-art car where you are driving. But if you take an autonomous car, and this is actually the reason or the other reason why we established this program, legal aspects of autonomous driving, to look into liability, who's liable for an accident like this? And the answer, of course, is, again, it depends. And it's not just the manufacturer or the operator who's no longer the driver, but there must be someone who presses the button, I want this car to go to this destination. So this person becomes the operator. And maybe for the manufacturer and the operator, or at least for the operator, it might be the insurance company, but there might also be other parties to this, like service providers. Like you were using like an online real-time mapping system that gave you wrong information that there actually was a speed limit in this section of the highway that was not in the map. Or maybe something like there was a detour that was not updated early enough. And so obviously it depends. And the solution to this might be to have a somewhat different insurance approach where you basically factor all of this in the belief that those vehicles will cause or will be involved in fewer accidents. Where you say then, sure, it has to be like a blanket coverage, first of all, the insurance pays for it, but in the end they have to pay for fewer accidents. And this is where we are discussing a lot, and there will not be zero accidents, because unfortunately there's no technology that's 100% safe. But fewer accidents and different accidents maybe. Because today we have accidents because people are texting while driving, because they are too tired to drive, because they are incapacitated for other reasons, or something like this. And there might be accidents because the sensor didn't have quite a clear picture of the scenario, or maybe there was one inaccuracy in the software code or something like this. This is something where it's actually pretty interesting to see how the technology field and the legal field seem to be progressing at about the same pace right now. So it used to be that it was only about technology development, but now it's something that the legal field is keeping up with it. And a good guess is that it will be special or especially tailored insurance policies for those vehicles.
Cambiar vidas,
change lives,
change organizations,
change
दुनिया में बदलाव,
change the world.